No
There you go.
worries. Hi, Andrew. Warm welcome to our DrayTek online training course. So we're running this to allow you guys to gain knowledge and features of the configuration options in DrayTek routers. So
Yep.
we'll be having some background theory and videos, but also a couple of hands-on exercises. So we'll start out today by looking at WAN connectivity options available in DrayTek routers. Tomorrow, Harvey will take us to multi-WAN and network reliability. Edward will follow up on Thursday with part 2 of that, focusing on high availability. And on Friday, Samuel will take us through VLANs. So in this session, we'll be looking at WAN connectivity options available in DrayTek routers. I'll go over some background information first relating to WAN connectivity, and then we'll have a hands-on session or two where we'll have a go at setting up and testing a couple of the different types of WAN connections. Here's an outline for the course. I'll start by introducing our routers, then we'll look at the different connectivity options available, which are listed here. So when we get to the hands-on, if you get stuck, we'll all be available to help out as needed, and we can come in with Zoho Assist Remote Desktop, and we'll give you a link to that in the chat box as well. Okay. So DrayTek routers support a variety of WAN connectivity options. These are available in either single, dual, and multi-WAN versions. Over the next few slides, I'll briefly point out the differences between them. Are you aware in Australia that NBN utilises a couple of different types of technologies to deliver high-speed internet?
Yes.
Yeah, so they call it the multi-technology mix as shown in this diagram. So you've got fibre to the premises, which has fibre going all the way from the NBN to the premises. Fibre to the curb, which has optic fibre going up to a pit, usually outside the street, within 100 metres or so, and from there it uses mostly VDSL2, but occasionally G.fast. Some of our routers are capable of doing G.fast, but it's not compatible with this because it needs power over Ethernet on the WAN port. Also, the ISPs have kind of monopolised that at the moment. Fibre to the node, we have optic fibre going up to a node within a kilometre or so of the premises, and the rest of the way it's copper using VDSL technology. Routers here will need a VDSL2 WAN port. Same with fibre to the basement, have fibre going up right up to the building of multi-dwelling units, high-rise and so on, and the node will be in the basement somewhere, and then we'll have copper going up to the apartments from there using VDSL. But they are rolling out G.fast as well here, and our routers should be compatible with this. Hybrid fibre coaxial, which is what I'm using here. You have a node, which is usually the telephone exchange. Then from there, it uses the old coaxial network rolled out by Foxtel originally and Optus. And then we have fixed wireless, where optic fibre goes up to a LTE base station and then wireless from there. And satellite, of course, goes all the way from the NBN to the satellite. I think there's 2 of them up there, and then down to the premises. There's also Elon's Sky Muster at the moment as well, competing with that. If you're interested in that, we did a report on it, some testing and so on, which you'll find in our knowledge base. Just get in there and search for Starlink. Sorry. All right, we'll continue on. So this table summarises the types of connections required by each type of NBN and which DrayTek routers are suitable with it. You'll find it on page 3 in the manual if you want to use it as a reference point, but I'll go into a little bit of detail about them as well. All right, so first up we have our single WAN XDSL routers. XDSL stands for ADSL, VDSL and other DSL technologies. So we had our Vigor 130, which has now been replaced by the Vigor 167. Those are a little bridge modem, or they can be used as a small router for up to half a dozen users or so, if you like. 2762 series has been replaced by the 2765 and 2766 series. The only difference between these two is that this one will support G.fast as well as VDSL2 and ADSL. Other than that, they're exactly the same. So if you If you want to future-proof a little by having G.fast capability, you can buy that, or if there's a price advantage over one on the other. And the main thing to be aware of is that they only support a single WAN connection. So the 2765 and 66 will support either ADSL or VDSL on that port. LAN port 4 can be configured as an Ethernet WAN port as well. And they also have a USB port, so you can plug in a supported 3G or 4G USB modem. Just keep in mind that while you can have 3 WAN connections, technically only one can be active at a time and the others can just sit there as backup. So this is where we get into our dual WAN routers, but they can support up to 6 WAN connections at a time. The 2862 has now been superseded by the 2865. And like the 2765 and 2766, the only difference between these two is the 2866 series will also support G.fast. And so the wireless models of these two as well can also support wireless WAN. So that's either 2.4 or the 5 gigahertz. And the difference between our dual WAN routers over single WAN is all these WANs can be active at once. So you can have 2 3G, 4G LTE modems plugged into 2 USB ports there. So effectively, you can have up to 6 WANs active at the same time, or load sharing or failover, however you want to set it up. Single WAN broadband routers, there's only one in the series at the moment. That's the 2135 series. And like the 2765 series, only one WAN can be active at a time. It also has a USB port for 3G or 4G backup, but it'll only do failover. So one of those can be the primary and the other one's just a backup. You can't have both active at the same time. And these ones can. The 2927 series replaces the 2926 series, and likewise with the 2962 and 2960. So where these differ is they don't have a VDSL2 modem. Instead, they have 2 gigabit Ethernet WAN ports. The wireless models also support Wi-Fi WAN on the 2927 series, and they also have 2 USB ports for 3G or 4G USB modems. 2962 has a 2.5 gigabit Ethernet WAN port and a gigabit Ethernet or shared SFP slot. So you can, you know what SFP is? It's for
it's a port pretty much.
Yeah,
but it can be adapted with the modules.
Yeah, you stick a fiber module into it or a DAC cable. And our multi-WAN routers, the big banger, the 3910 has replaced the 13900. So it has 4 gigabit Ethernet WAN ports, but the LAN ports are also can be configured as WAN ports as well. So it can support up to 8 WAN ports. Just those USB ports at the moment don't support 3G or 4G LTE modems, but we'll sort of put that on our wish list for that model.
So just to clear up,
yep.
The single WAN is one connection at a time. Dual WAN is, I assume, you can only have 2 of any of the options that you have at the same time, and the multi-WAN is all of them.
It varies. If I go back a couple of slides there.
Oh, my bad.
Yeah. The dual one we need to rename it as multi-WAN. Multi-WANs, they have multiple. They can have all of them at a time. And then you got the single one where there's only one, right? The dual one, I don't like to use that term, but anyway, sometimes we use it.
Yeah.
Sure.
That's essentially it. Like the 2927 series here can have up to 6 WANs active at once. The 2962, it has LAN ports as well that can be configured as WAN ports, but it can only support any 2 of whichever combination you like. So this port could be used as a LAN port as well, and your LAN port, one of your gigabit LAN ports could be configured as a WAN port. But that's all on the product page, if you forget that.
And did you get
no worries.
Andrew, do you get the Wi-Fi WAN? You know what that is?
Wi-Fi WAN, I don't know what it is, but my best guess would probably be the wireless version
If
of.
you have a Wi-Fi, if you have an office next to you and it give you Wi-Fi, you can collect this Wi-Fi
gotcha.
and put it as a WAN, right? So
Yep,
the advantage
gotcha.
is you can have two ports, one on the 2.4 and one on 5 gigahertz.
Yeah, exactly.
So that's
But,
two additional ones.
Yeah, you can also connect that to your mobile phone's Wi-Fi hotspot. So
Yeah.
if your usual internet connection's gone down for whatever reason and you need an emergency backup, you can fire up the hotspot on your mobile phone and connect the router to that.
Yeah, but the Wi-Fi one, the router needs to be an AC version, right? The 2927 AC or 2865 AC, or else you won't have Wi-Fi. Okay, that's it.
Okay, lovely. Cool.
All right.
Sorry, feel free to continue now.
Yeah, you're right.
Thank you.
So yeah, we've just covered this quiz question. What's the main difference between single WAN and multi-WAN? And you answered it already, that single WAN, only one can be active at a time, and the dual or multi-WAN routers allow all WAN connections to be active, except for the 2962, which is any two. Next, we have our LTE routers. So these two here, the 2620L and LTE 200 series, they're still available, but we're no longer bringing them in because the latest LTE modules that DrayTek are putting into it exclude some LTE bands, including the 700 megahertz band that Telstra uses. So yeah, because of that, we just thought we won't bring them in. And so these guys, the main difference with that LTE router is they have a SIM slot, which you can see down there. So you can put 2 SIM cards in, and as well as having the ADSL or VDSL2 WAN port and a gigabit Ethernet WAN port. But again, single WAN, only one WAN can be active at a time, and the others can be backup.
And the 2 SIM card, only one at a time.
Yeah, yep. The SIM cards purely have a primary and a secondary, and it'll only act as failover. You can't have both SIMs active at the same time. And that's the same situation with these guys. So these will support multiple WAN connections at once, but with the SIM situation, only a primary and a secondary as a backup. Yeah, and there's a table here which you'll find on page 11, which shows the differences in the WAN ports between all of those. And the main thing here is WAN 5 can be the embedded LTE. They still have a single USB port, which you can also plug a 3G or 4G USB modem into.
What does it mean by embedded? Is that like eSIM?
Yeah, it has like an LTE modem built into it, and so then you just need to put a SIM in, not the whole USB modem into the USB port.
Yeah,
Okay,
the advantage when you have an embedded LTE is you can get your public IP. It goes straight to the router. Whereas if you use a USB dongle, you will get a NAT IP address.
Yeah, that's it. You get a private IP address, and they're usually NATed as well. Whereas with an embedded LTE, you get around that in most cases. Okay, so the main difference in LTE routers is that, as you answered, they have an embedded 4G LTE modem inside them. All right, that should be a bit clearer in this video that I'll play for you now. So this video takes through the configuration, including how to install the SIM. The DrayTek Vigor 2865L series, Vigor 2866L series, and the Vigor 2927L series routers come in both Wi-Fi and non-Wi-Fi versions, and all have an integrated LTE modem which accepts SIM cards from any of the major broadband service providers in Australia, such as Telstra, Optus and Vodafone, as well as those in New Zealand like Spark, 2 Degrees and Vodafone. For supported bands and other details, check out the links in the description below. Setting them up is very straightforward. On the back of the router, first remove the cover using a small Phillips head screwdriver. Inside you'll find 2 slots. The bottom slot is for the primary connection and the top slot can take a second SIM to act as a backup connection if the primary connection goes down or is otherwise unavailable. Insert the SIM with the notch on the left-hand side and then replace the cover to prevent accidental removal of the SIM or dust getting in. Then attach the LTE antennas. These are the ones with cables and they go on the 2 connectors towards the centre of the router on Wi-Fi models. Then log into the router and go to WAN General Setup. Click on the LTE WAN connection, make sure it's enabled, then type in a display name. This can be anything you like. We'll call this one Optus LTE. Then under line condition detection, select the mode as ping detect. Then click OK. Then click OK again to save the settings and reboot the router. When it finishes rebooting, go to WAN Internet Access. For the LTE connection in the pull-down menu for access mode, select 3G 4G LTE modem DHCP mode. Then click on Details page. Click on Enable, then enter the APN name for your ISP. In this case, we're connecting to Optus, so the APN name is Yes Internet. For other common APN names, click on the FAQ link in the description below or check with your ISP. Select Disable Auto APN and click OK. Now go to Online Status, Physical Connection to see if it has connected. Green text and a valid IP address indicates that it has. Other details here to show we're online include the uptime, TX and RX rates, and information about signal strength and quality. We can also see more details under LTE status. We can run a ping test to check the quality and latency of the internet connection down under Diagnostics Ping Diagnosis. Simply enter an internet IP address and click on Run. After a few seconds, we get the result, and apart from that first one, which we'll put down to a hiccup, we see almost instant replies, which is great. You can also run a ping test from your PC using command prompt. Just type in ping 8.8.8.8 or some other internet IP address or domain name, and then enter. The replies here show a little more latency because of the extra hop between the PC and the router. And that's all there is to connecting a DrayTek LTE router to the internet using a SIM. All right, let's now get into the WAN connectivity options. So for DSL connections, we'll start with ADSL. Mostly that's been replaced by NBN in Australia, which uses VDSL2, but we still have quite a few customers using that in some remote areas. So for ADSL, we need to select the correct parameters and modulation mode to get an internet connection. These are on the Internet Access configuration menu. The default modulation is set to multi-mode, which will try to auto-detect the modulation required. Alternatively, you can manually select the required modulation. Other settings are VPI, VCI, protocol, and encapsulations. This table shows the different settings required in Australia and New Zealand. In Australia, VPI is usually 8 and VCI 35. Protocols can vary, but it's usually one of those two. And encapsulation, I think, mostly is LLC Snap, but occasionally VC Mux. VDSL2 is similar to ADSL2, so it has a theoretical maximum speed of 250 megabits per second at the source, but it drops off quickly up to half a kilometre. And then by the time we get out to 1.6 kilometres, it's much the same as ADSL from there. So in most cases, the ISPs will only approve a fibre to the node connection up to about 1 kilometre from the node, so they can guarantee the performance. This picture here is what a node looks like, a little green cabinet on the side of the road. So as we saw in that NBN diagram earlier, we have fibre going right up from the NBN to the node, and then we have copper, VDSL over copper from there to the premises. There's a number of different firmware versions for VDSL routers which have different modem codes. You can select the modem code from the pull-down menu in the middle there. And there's also different firmware versions you can download with different modem codes. No hard and fast rule there. It's really a matter of trying different firmwares, testing it out and seeing if it's any better or worse than the previous one, and then choosing the best one at the end of it. You'd only bother with that if you were having stability issues or speed problems or something like that. Some service providers require a VLAN tag for the WAN connection. So that this table here shows the most popular ones for Australia and New Zealand. Where's my mouse? There it is. Most of the time they use a VLAN tag of 100 in Australia, but there are a couple of exceptions. TPG sometimes uses 2. Belong Internet is 900. Telstra Business Fibre uses 101. In later firmware versions, you'll notice that you have customer and service VLAN tags, which can be confusing if you're not sure which one to use. It's recommended to use just the customer tag setting in Australia. So the customer tag is also known as the inner tag, and this is added only to the primary WAN channel, whereas the service tag is known as the outer tag and is added to the primary channel as well as the other channels set up on the same interface. So that's mainly when you get into IPTV and that sort of thing. All right, moving on. In May 2022, NBN enabled SOS at Save Our Showtime and ROC, Robust Overhead Channel on VDSL lines to improve stability. It does that by preventing dropouts due to sudden large noise bursts. Older model routers don't support it, but new firmware was developed to support bidirectional dynamic SRA, seamless rate adaptation, which is sufficient to provide a stable connection on SOS ROC enabled VDSL lines. The chart here summarizes the compatibility of routers with SOS ROC. So all of these guys are our older model routers. They don't officially support it, but they will support SRA, which usually is sufficient. And that's one of the reasons why the Viga 167 superseded the 130, so that it had this capability. To check the current SRA setting, you can run the telnet command VDSL OPTN RSA ? And you should see something similar to this. So it's the command there, and this is what we got back. It showed us SRA mode for upstream is 4 and downstream is 4 as well. So you'll find that in the workshop manual on page 18 if you want to give it a go. And if you encounter difficulties with the ADSL or VDSL, you can go to the diagnostics DSL status page for line statistics down here, which will help you troubleshoot the issue. A number of application notes and videos are available in our knowledge base. There's a couple of examples here, and you'll find these in the manual on page 20. Or just get on our knowledge base and search for whatever it is you need to know. And if you're trying to work out how to bridge a Viga 167, you'll find that just by typing bridge mode or Viga 167, it'll give you everything we've got on that in there. All right, the last type of DSL connection, which I mentioned before, is G.fast. This one's supported in the 2766 and 2866 series routers, and they can offer a download speed of up to 1 gigabit per second. Just as I mentioned, DrayTek G.fast routers aren't compatible with NBN, where PoE is used for the NBN distribution point unit as the DPU used in fibre to the curb in Australia. But these routers are also backwards compatible with VDSL2, so they can use those as well. Yeah, so basically, if the 2866 is coming up cheaper, even if you don't need G.fast, you can grab it and it'll still work fine on VDSL2. Next one we'll look at is Ethernet WAN. So this uses twisted pair Ethernet cable to connect a router to the internet through a modem or an Ethernet termination port. chart here shows the different types of connections where Ethernet WAN is used and the suitable routers. That's pretty much all of them except the Vigor 167. The lower end routers like the 2765, 66 Ethernet WAN port, LAN port 4 can be configured as a WAN port, and all of the 2865 have both VDSL and Ethernet WAN ports. If you need 2 Ethernet WAN ports, then products like the 2927 is the way to go there. Here we have a fibre to the premises installation. So we have our fibre coming into the NBN utility box, then to an outlet on the wall, then to the NBN connection box or network termination unit. And this is what we plug our router into. So you'd usually have an Ethernet cable coming out of that, which you can plug into your router. There's 3 modes you can select for Ethernet WAN. The most common are PPPoE or DHCP. I don't think this PPTP, LTTP comes up in Australia at all, but you'll find those under WAN Internet Access in the router interface, and tabs up here for whether you're trying to connect by PPPoE or static or dynamic IP, or PPTP if that ever becomes available here. And there's also an IPv6 tab. And application notes and videos listed here provide configuration examples and videos showing how to configure DrayTek broadband routers for NBN. Some of these are for older model routers, but the later model routers have similar menu options, so the configuration steps will be similar. You'll find that in the manual as well on page 28. USB WANs, we touched on this before, so if you go to the support tab on our web page, you'll find a chart which will tell you which of these USB modems are compatible with different router series. The old Sierra 320U is still popular. Netgear bought them out a while ago, so it's the Netgear 320U now, but I'm not sure if you'll find these new now, but there's usually heaps of secondhand ones that come up on eBay and so on. If you can't get online, you'll find the supported modem list in the router's GUI as well. That's under USB application modem support list. That'll show you which USB modems have been tested and known to work. There's 2 access modes available for USB modems. Those are PPP mode and DHCP mode. Note that most 4G USB modems will only work in DHCP mode. Few points to note when using USB mobile WAN is that most service providers only allocate a private IP address. I've mentioned this before. This can cause problems if you have incoming connections such as VPNs, or if you want to redirect the port. Now, with some service providers, it's possible to request a public IP address, but others can't or won't give that to you. Another one is that most modern USB modems run in NAT modes, so that'll cause problems as well if you need to use port forwarding. And some of these issues are addressed by using the LTE routers with the embedded LTE modem that you just need to stick a SIM in, which we'll go through next. And here we see that here. We have the LTE WAN in the 2865L, 2866L and 2927L series, which have a built-in SIM card slot. So these routers are unlocked and accept SIM cards from all the major service providers. And as mentioned, where you get 2 SIM card slots, and one is the primary, one is the secondary, you can't have both of those online at once, just one will act as a backup to the other. Supported bands, if you're interested in that, you'll find it on page 34 in the manual. I won't go into detail with that, that's a bit boring. All right, let's have a go at setting this up. Do you have a SIM card you can use there, Andrew?
I do, yes.
Beauty. All right, so this is our first hands-on session. You'll find it on starting at page 55 in the manual, and hopefully you know the APN and other details that you need. If you get stuck, just sing out and one of the guys can come in with a Zoho session to help you out.
Sure thing.
No worries. So we'll give it 15 minutes, but if you finish before that, just sing out and we'll get back into it.
Sure thing.
All right, so now we'll look at Wi-Fi WAN in a little bit more detail. So you'll find that in dual WAN Wi-Fi routers like the 2865 AC and 2927 AC. And it allows you to connect the router to any Wi-Fi hotspot or mobile phone, which can be useful in an emergency situation when you've lost your usual WAN connection.
Yep.
In current model dual WAN wireless routers, you'll find WAN 3 and WAN 4 can be configured as Wi-Fi WANs. In older model routers like the 2862 AC, you had to configure WAN 2 for Wi-Fi WAN, which meant losing the Ethernet WAN port. But now you can have wireless WANs on both 2.4 and 5 gigahertz, and you can have all these other WANs active at the same time. Okay, let's have a look at a video that Edward made about this, showing us how to set it up and how it works.
Greetings everyone, my name is Edward Arroy. I'm here to introduce the wireless WAN feature on DrayTek routers. Here is our outline for the topic. What is wireless WAN? Get online from any wireless hotspot. Emergency broadband backup solution. Benefit from ISP's Wi-Fi access. Feature products, and lastly, setting up wireless WAN. What is wireless WAN? One of the router's most valuable feature is its capability to connect to a wireless hotspot and grant internet access. This is especially beneficial during emergencies when the primary internet connection is unavailable. The router can be wirelessly connected to a Wi-Fi source using its wireless WAN features. Get online from any wireless hotspot. With a wireless WAN, the router can connect to various sources, including personal hotspots on smartphones, portable Wi-Fi hotspots, ISP wireless hotspots, and private wireless network. Emergency broadband backup. If your internet service goes down unexpectedly, you can use your smartphone to set up personal hotspot for your router to connect to. This will ensure the entire network has internet access if there is a network singular data connection. Wireless WAN is the fast and efficient solution for unexpected outages of fixed line services. Various internet service provider offers Wi-Fi access for their clients at a certain location. The wireless WAN capability of the router enables it to connect to the ISP's wireless network whenever it is available. Feature products. We offer a variety of routers that supports wireless WAN, including the Vigor 2866, 65, 62, and 60 series, Vigor 2927, 26, 25 series, and the Vigor 2915 models. Notably, the Vigor 2866 and 65 and Vigor 2927 models are equipped with two WAN interface for both 2.4 GHz and 5 GHz without sacrificing a WAN port. However, older routers convert their WAN 2 interface to function as wireless WAN. Moreover, our routers that support wireless WAN are multi-WAN with Wi-Fi built in, except for the AX model. In the diagram as shown, I will connect the mobile hotspot to the 2.5 GHz network. Meanwhile, the private wireless access point will be connected to the 5 GHz network on a wireless WAN feature of the router. begin, activate the mobile hotspot feature on your smartphone. Then access the router's web management. Simply enter the appropriate username and password. Once you have accessed the router's web management, navigate to WAN, General Setup option, and activate both WAN 3 and WAN 4. Remember that WAN 3 refers to the 2.4 GHz wireless WAN, while the WAN 4 corresponds to the 5 GHz option. To apply WAN settings, the router needs to be rebooted. Then log into the router after it reboots. Then go to WAN, Internet Access. Under WAN 3, select Access Mode to Static Dynamic. Then, tick Details page to set up the configuration. Now enable Static or Dynamic and select Obtain an IP address automatically. Then tick AP Discovery. Tick Scan to see all Wi-Fi network in your vicinity. Select Galaxy S20 FE 5G CC40 from the list. Enter the correct pre-shared key and click on OK to confirm the changes. The router will restart to implement the new settings. To access the router, simply log in to the dashboard. Once you're in, you will see the WAN 3 is connected and has its unique IP address. To connect to a private wireless access point using the wireless WAN 5 GHz, follow the same procedure as WAN 3. Select the IP Discovery, scan, and choose the SSID you want to connect. Please choose Add-on Technology. Check the Add to the box, apply pre-shared key, and finally click OK. The router will reboot to apply the configuration. To confirm, please check if WAN 4 has received an IP address on the dashboard. To check the internet connectivity, access the traceroute feature in the diagnostics section. To traceroute, use WAN 3 on 8.8.8.8 and WAN 4 on the same IP address. This will appear the hops and show that the destination has been reached.
Okay. The other type of WAN connection we have is SFP ports. The 3910 pictured here has SFP plus slots, which will go up to 10 gigabits a second. They can also be configured as LAN ports, so you can uplink them to a switch using optic fiber or a DAC cable, and DrayTek have some DAC cables available in a couple of different lengths as well. Now, we were going to have a hands-on setting up Wi-Fi WAN, but I understand your computer there doesn't have a LAN connection to be able to connect to the router, or have you got one now?
I've got one now. It's all set up.
All right, we'll continue on. All right, so now we'll briefly go over some details of what's involved in establishing WAN connections. This will help with troubleshooting, hope possibly with the Wi-Fi connection there as well.
Yep.
Okay, so as we covered previously, there's 5 different types of WAN connections. That's XDSL, broadband Ethernet, 3G, 4G, LTE, USB dongles, built-in SIMs for LTE, and wireless WAN. For each of these, there's usually 3 steps involved in establishing WAN connections. First, there's the layer 2 settings, then layer 3 settings, followed by online status verification. Before a connection can be established, a physical link needs to be set up between the router and the service provider. That establishes the data path over which the authentication credentials can be exchanged with the service provider before being granted internet access. ADSL and VDSL WAN interfaces first need to detect a signal on the copper pair coming from the service provider DSLAM. Once a signal is detected, the router will go through several stages where it will synchronize with the DSLAM and lock the connection. You'll see a training stage to synchronize the modem. Then when the physical link's established, you'll see showtime appear on the router online status page. Broadband Ethernet uses twisted pair Ethernet cable to connect a router to the internet through a modem or an Ethernet termination port. The Ethernet WAN interface can be configured to use auto negotiation or a fixed speed and duplex setting. When a physical link is established, the link lights on the router are what tells you that it's working, and also a link light on the attached equipment as well. With USB modems and integrated LTE modems, the service provider wireless signal has to be detected first, and the router will establish a physical connection to the 3G, 4G network based on the APN. That's the access point name specified in the router settings. Wireless WAN uses the router's Wi-Fi to set up as a WAN connection to the internet through a Wi-Fi hotspot. That's the one we've struggled with just now, for some reason won't connect. Now, a lot of NBN connections require a VLAN tag on the WAN interface as well, which we covered briefly earlier today. Once the physical link has been established for the router WAN interface, the next step is to authenticate with the service provider and get an IP address. There's three common methods used to obtain an IP address. The first is PPP dial-up, which requires a username and password. Next methods are dynamic IP, DHCP, where the router automatically gets its IP by DHCP, and static IP, where you manually enter the configuration details for IP, subnet mask, and gateway. Once the WAN connection has been established, the details can be checked in the online status page of the router. The router WAN IP address and gateway IP will be displayed in green text, and you usually also get some TX and RX information as well as the uptime. So if you're not sure if the router's rebooting or it's the internet connection is dodgy, a good indication is to compare the system uptime with the WAN uptime. When PPPoE authentication issues are encountered, it helps to understand the processes involved when you need to troubleshoot and find out what's causing the problem. There's 6 stages involved, which are listed here. I won't go into details of those bit by bit, but you can see them when you capture the router WAN data packets using Wireshark. If you want to go through that, you'll find that on page 50. There's 3 steps to troubleshoot PPPoE connectivity issues. First, obviously, check the physical connection. Sometimes it can be as simple as a loose cable or a dodgy cable. Next, capture the WAN packets using Wireshark and follow the data path at each stage of the PPPoE authentication. Finally, if you come to a dead end, send the Wireshark capture to us along with the router details, and we'll analyze it and see if we can figure out what the problem is. Next one we'll look at when establishing WAN connections is the MTU size. So MTU is an abbreviation for maximum transmission unit, which is the largest protocol data unit, that's PDU, that can be sent in a single network layer transaction. The maximum MTU size for an Ethernet frame is 1500 bytes. The maximum Ethernet frame size is 1518 bytes. And if we take away 18 bytes for overhead, that's the header and frame check sequence, it gives us a value of 1500. Larger MTU sizes are more efficient as it allows more data to be transmitted in each packet. However, overhead in internet connections will require the MTU size to be reduced to cater for the overhead. For example, PPPoE uses 8 bytes, the header uses 8 bytes, and a VLAN tag uses 22 bytes. So for an internet connection which uses PPPoE, the MTU size will be around 1492. I can remember also when ADSL first rolled out, a lot of us tried to use Microsoft's built-in internet connection sharing, only to discover that it wouldn't work. We could ping websites, but we couldn't load them. And it turned out that the problem was MTU size due to the PPPoE overhead. The solution back then was to hack the Windows registry, but there was a tool called Dr. TCP available that made that a bit easier as well. So what happens when a large MTU value is used, which I just described there? IPv4 allows fragmentation, which divides the datagram into pieces, each small enough to accommodate a specified MTU limitation, but this can cause unnecessary overhead and slow down communication. For VPNs, a large MTU size can cause data loss, resulting in failure to establish the VPN connection. Several methods you can use to determine the optimum MTU size to use. The first is to use a ping test. Here you ping the remote host using a set packet size and reduce it until you don't get fragmentation. So in this example here, we see Roy's set a packet size of 1473 bytes, and that came back with an error saying packet needs to be fragmented but DF set. So then he tried it with 1472 and that worked fine. So our maximum MTU size is 1472 bytes in this case. Second method to use is Path MTU Discovery Tool, which you'll find in DrayTek routers. So all you do is click on Detect and it'll determine the best MTU size to use for the WAN connection settings. There's also tools on the internet that you can use to work out the best MTU size to use as well. Okay, so two methods to use to check the optimum MTU size. Ping test
and discovery tool.
And the discovery tool, yep. Right, that's it for today. So we looked at the different types of routers, which were XDSL, broadband, and LTE routers. Those are available in either single, dual, or multi-WAN versions. We also looked at the different connection types, including ADSL, VDSL, Ethernet, LTE, and wireless WAN. We had a brief look at the steps involved in establishing WAN connections, as well as why you need to consider MTU. We also had a couple of hands-on exercises, which were mostly successful, except for that last one, which wouldn't seem to connect for some reason. All right, that's it. Any questions?
Nope, that's all good. I understand all of that.
Too easy.